So we were given that cotangent, I think I changed it, of theta equals 1 plus cosine 2 theta over 1 minus cosine 2 theta. Well, I'm going to look at those cosine 2 theta, and I immediately have to go to my double angle formulas. Because you have to rewrite those immediately. So let's hopefully I still have those saved somewhere. Way up there. All right. Well, the problem is there's 3 possible ones to redo it. So you could just do trial and error, but that's a whole lot of possibilities. So let's go back to the problem. And look what the left-hand side has to equal. It has to equal cotangent squared theta. Well, cotangent is just cosine squared theta over sine squared theta, which is a good idea to rewrite that because you have cosines on the other side. So why not rewrite it in terms of cosine and sine? All right. That means, to me, what that's telling me is I want just cosines up here, and I want something that just has sines down there. So then I go to my double angle formula, look at the 3 ways to rewrite it. Well, one way we can rewrite it with just cosine is that one. And there's a way to write it as just sine, and that's that one. So on the top, I want it to be the cosine one. So I'm going to have 1 plus, and I'm going to change my cosine. Instead of cosine 2 theta, I'm going to use that 2 cosine theta. So this one here. So I'm using that 2 cosine squared theta minus 1. And then on bottom, I'm going to rewrite that one in terms of sine. So I'll have 1 minus, and I'm going to change that cosine 2 alpha to 1 minus 2, not cosine, but sine squared theta. Well, this is 1 plus minus that. That will cancel out and turn to 0. This is 1 minus 1 because you distribute that 1 to both of these. So it would actually be 1 minus 1 plus 2 sine squared. Well, that would give me 2 cosine squared theta over 2 sine squared theta, and I would be done. All of these identities, if I'm asking you to do identities in this section, you should look for the ones that say cosine 2 alpha, cosine alpha over 2, something like that, because you should immediately rewrite it using your identities, which will be provided for you on the test. All right, other questions? Jack?
3 and 7.
Say that again?
3 and 7.
3 and 7. Well, 3 is giving you tangent of 3 pi over 8. And it says to use the half or double angle. Double angle wouldn't work here. We're going to have to use the half angle. So I'm going to rewrite that as tangent of 3 pi over 4 over 2. Because what we do is we double our angle and then we divide it by 2. Well, 3 pi over 8 times 2 would be 3 pi over 4, and then we divide it by 2. So these two things are the exact same. Now we go to our half angle identities. And there's one in particular you should use every time for a problem like this. And that is that bolded one, so I'm going to use this one. And it'd be 1 minus cosine that value over sine that value. So that equals 1. Did I pick the right one? Yeah, I picked the right one. 1 minus cosine. Right, a minus. All right. 1 minus cosine 3 pi over 4 over sine of 3 pi over 4. And then it's just using the unit circle. All right, 7 is No different than the ones we've been doing. We are given cosine 3x. We are given cosine 3x equals cosine x 1 minus 4 sine squared x. So on the left-hand side, I'm looking at that and I'm thinking to myself, well, I don't have a triple angle identity. I don't have one that says cosine 3x equals something. So that means you need to split it apart. You need to split it apart into cosine of 2x plus x. Well, we can rewrite that using that angle addition for cosine, which would give us cosine of that first angle, which is 2x, times cosine of the second angle, which is x. And then it's minus sine of the first angle, which is 2x, times sine of the second angle, which is x. Break this apart a little bit. All right, now we have to recognize that we have cosine 2x and sine of 2x. Well, sine of 2x is really easy to rewrite. There's only one way to do it. If you look at your double angles, there's only one way to rewrite that. It is 2 sine x cosine x. So we're going to rewrite that as 2 sine x cosine x. But let's not forget about putting that sine x, bringing that sine x down. All right, the only trouble you should have is rewriting cosine 2x. You have to decide, I have to decide how I'm going to rewrite that. Well, if I look at the right-hand side, I don't have any cosine squares. I only have cosine x, which would distribute there, and cosine x, which would distribute here. So there's absolutely no cosine x's squared. So that means I don't want to pick a cosine 2x that has a cosine squared in it. And then the one that doesn't have a cosine squared in it is rewriting it as 1 minus 2 sine squared x. We bring down our cosine x. And then, just to shortcut stuff for the sake of time, I wrote it as that. I distributed everything, and it all condenses down to what's on the right-hand side. So the rest is just basic algebra. Is that far enough, or do you have a specific question? No? Okay, other questions? Brody. 11, we're supposed to find all real solutions of sine 2 alpha equals sine alpha. So that was kind of a step up from where we left off the prior day. The first thing you have to do anytime I ask for all real solutions or I give you something that's number that's not an identity, you get all your trig functions on one side and all your numbers on the other side. So that means subtract 2 alpha. Well, that gives me sine of 2 alpha minus sine alpha. The problem is I can't set either of those equal to a number yet. I don't have, sine alpha equals 0 or sine 2 alpha equals 0. So the only way to do that is to factor. But you can't factor sine alpha out of both of these because these are different things. One is 2 alpha, one is alpha. So the only way you can actually do this problem is to actually use your double angle identity. I know we don't always use it. That is a last resort, is to actually use our double angle identity. But we have to use our double angle identity here to write 2 sine alpha cosine alpha. Now I can factor out a sine alpha, and I can create that zero product property, where I have either that equals 0, or I have that 2 cosine alpha minus 1 equals 0, which I simplified to cosine alpha equals 1/2. And from there, I think you can get it from there. So realistically, this is what you're looking for on problems like these. If you get everything to one side, and you have too much stuff over there, you can't set it equal to a number, it means you have to factor something out. You have to factor something out. Either you have to turn it into a binomial times a binomial, or you have to look for being able to pull sine out. And since we couldn't, that's the only reason why we had to rewrite that double angle. Writing out your double angle is your last resort on a problem like this. It should not be the first thing you try to do. Other questions? Leo. 5 is actually one I think I pulled out straight from the homework. I believe we already did this one, so I'm not going to spend a whole bunch of time on it. But it's basically, if you have sine of x over 2 equals -1/3, you're going to write what sine of x over 2 equals. And it equals square root of 1 minus cosine x over 2. Now let's look at for the stuff that I can plug in. Either I could find the cosine x, or I know this value. In this case, I know sine of x over 2 equals -1/3. So I replace that with -1/3. And then I just use algebra to solve for cosine, which is 7 over 9, which can easily get me sine, because sine squared plus cosine squared equals 1. Yeah?
Isn't like 16 times 2 equals 32?
Oh, did I make a mistake somewhere on here?
This is like the square root of 32. Can you like factor out like...
Oh, yeah, I could, but see how we're just looking for cotangent x?
Yeah.
You don't need to simplify these if you don't want to.
Oh, okay.
Because the only answer I'm looking for is that cotangent x value at the end. That's why it's the only one I have boxed in. If I ask for your sine, your cosine, and your cotangent value, so if I ask for all three, then you would have to simplify this down. Okay?
I still got the wrong answer.
Oh, you still got the wrong answer? So you reduce this down to, what, 4 square root of 2?
Yeah.
Which is what I had here. That's where that 4 square root of 2 is here.
Okay.
So you probably just did something wrong with your fractions. All right, next question. Brian?
Number 2. I just have a question about yeah, I just don't know what I did wrong.
Well, we should have written it as a half angle. And 22.5 is 45 divided by 2. You plug it into the only cosine one we have, which is 1 plus cosine 45 over 2. Well, cosine of 45 is square root of 2 over 2. I multiply the top and bottom by 2. Don't forget to distribute your 2. So that gives you 2 plus square root of 2 all over 4, and all that's over a square root. And it's ending up being a positive because 22.5 is in quadrant 1.
I forgot to use the square root, like 2 plus square root of 2 over 4.
Oh, okay, gotcha. Yep. All right, let us go on to today's lesson. Today's lesson is we're going to start talking about the law of sines. Up until now, when I talked about sine, cosine, and tangent, you always had to have a right triangle. And don't forget about these, where sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. That's where our SOHCAHTOA came from. I also put on here inverses. If we have sine alpha equals opposite over hypotenuse, I could take the sine inverse of both sides to get my angle equals sine inverse of opposite over hypotenuse. That is just taking the sine inverse of both sides. Sine inverse is what cancels out sine and gets your angle all by itself. Problem is, this only works for right triangles. And there's a ton of other triangles out there that aren't right triangles. Good news is we have something called the law of sines. The law of sines will expand our possible search for answers of triangles, but they have to match a specific set of requirements. Primarily, you have to know 2 angles and a side for these to work. So you can either have angle, side, angle, or you can have side, angle, angle. You don't really have to concern yourself about naming them. That is just, you need to know 2 angles and a side. If you know 2 angles and a side, you can use law of sines. Once again, angle, side, angle, and side, angle. Angle is how I'm going to name them, but just know you just need to have 2 angles and a side. That's going to be imperative that you know that. Because tomorrow we're going to talk about different triangles where you have side, side, angle. And then we'll expand it to all triangles when we bring up the law of cosine. So this right here is really important for you to know. That will you'll be able to get it right or wrong based upon you knowing if you know two angles and a side, that means law of sines. All right, as soon as we know that, we can use this new law. And the law of sines says, well, sine of A over side A is always going to equal sine of B over side B, which will always equal sine of C over C, given that triangle over there. I do want to put some notes down on that triangle. Oftentimes we don't put C. We'll often use gamma. For A, we'll oftentimes use alpha. And for B, we'll oftentimes use beta. All right, so if you ever see those, if you see gamma, just know the opposite side is side C. If you see alpha, the opposite side is A. And if you see beta, the opposite side is B. I'm also going to add something. There are two versions of the law of sines. This is the one you'd see in a book. This is typically one you'd use to find an angle. So if I miss an angle, I typically use this one. However, if I'm missing a side, I'm going to change this a little bit. If I'm missing a side, I'm going to change this and I'm going to take basically the reciprocal of all of it. So A over sine alpha is going to equal B over sine beta equals C over sine Charlie. This is the one I'm going to use to find a missing side. It is not crucial you know both of these. It is crucial you know this one. This one is just a nice shortcut if you're missing a side, so you don't have to do cross multiplication and do weird stuff. All right, that is the only reason why you use this. It simplifies the process a little bit. Let's make sure our phones are all off. Otherwise, I'm going to figure out whose that is. So make sure our phones are off, whoever's that was. All right, if it goes off again. All right, sine alpha over A. You have to know this one. All right, let us go on. All right, we're supposed to solve triangle ABC where B equals 34 degrees, C equals 64 degrees, and A equals 5.3. So the first thing I'm going to do is I'm going to draw that triangle. I'm just going to draw a standard triangle. Any old triangle where we have a A, a B, a C. This is my side A, this is my side B, this is my side C. So we know B is 34 degrees. We know C is 64 degrees. And we know A equals 5.3 degrees. So we are given angle, side, angle, which means use the law of sines. So I said you have to know how to check your triangles. This will tell me specifically to use law of sines to find the rest of them. So it does say solve the triangle. Solve the triangle always means find any piece of information that's missing. So we're missing angle A, we're missing side B, we're missing side C. So first, it's probably a good idea to find angle A. What's the measure of angle A? Rena?
82 degrees.
How'd you get 82 degrees?
I subtracted 34 and 64 from 180.
Yep. They all have to equal 180 degrees. So if I've given two angles, you better just find that third one. It's worth points. All right, now I'm going to go ahead and I'm going to find side, I don't know, it really doesn't matter which side I'm going to use. Let's find side C. Well, using the law of sines, I can say that C over sine of C is going to equal, now what you're going to do now is you're going to pick the angle and the side you know, because it doesn't pay to have a whole bunch of unknowns. So we're going to pick angle A and side A. So that's going to equal A over sine of A. Well, we don't know C. We don't know side C. That's what we're looking for. But we do know the angle opposite side C is 64 degrees. So we'll say that equals the sine of 64 degrees. Is going to equal, my A value is 5.3. And we'll have a sine of angle A. Angle A is 82 degrees. Well, the whole reason why I flipped these for these is because now I just have to multiply by sine of 64. Picture if these are flipped. If you had it flipped like the normal one, you'd have sine of 64 degrees over C equals sine of 82 degrees over 5.3. You'd have to multiply everything by C, and then you have to flip this and multiply it on the other side. So it's much easier if you just recognize what you need and put it on top. I need to find C, so I'm going to make sure my sides are on the top. Because now I do just have to multiply both sides by sine of 64. And our C is going to equal sine of 64 degrees times that 5.3 over sine of 82 degrees. So you will definitely need your calculator for this stuff. And correct me if I'm wrong, for people who have calculators, I would go ahead and do this if I was you. But I think I came out with about 4.8. It might be slightly off because I think I did a little different. I found B last time. Top. So we'll always put what we're missing on top. So we'll say B over the sine of angle B. The sine of angle B is 34 degrees. Well, that's going to equal, now, here's a little pro tip. I found C. I'm probably not going to use the one I found, because what if I made a mistake? Then I'm using a wrong number to find that. So I'm going to go ahead and use the information that they gave me. They gave me side A and angle A. Well, we know angle A is right because we just did this. So I'm going to use the side that they gave me. So I'm going to use A over sine A because that's information they gave us. So reducing that down, we have B over sine of 34 degrees equals our side A, which is 5.3, over sine of the angle A is 82 degrees. Multiply both sides by sine of 34, so I'm left with just B on this side. And that's going to equal B equals sine of 34 degrees times 5.3 all over sine of 82 degrees. Can someone plug that in and get that number for me? Rita.
It's just about 3.
It's just 3. Yep, that's what I got. All right, now let's double check. I was missing side B, found it. Missing side C, found that one. Missing angle A, found that one. I'm done. Triangle solved. All right, questions on any of those steps? All right, now we'll go down to this one. Now we have triangle ABC where our angle alpha is 420, or our side A is 422. Our angle is 30 degrees, and angle C is 110 degrees. So once again, I'm just going to draw a triangle. I'm going to make sure it's possible to even use the law of sines. So let's label this A, B, C. Well, it said side A equals 422. I don't know side B. I don't know side C, but angle C is 110 degrees. Angle A is 30 degrees. So they gave me angle, angle, side. Angle, angle, side means I can use the law of sines. Well, right off the bat, I'm going to say 30 and 110. That means I'm going to find my angle B right off the bat. So B is going to equal, well, 110 plus 30 is 140, so B must be 40 degrees. That should be a money in the bank point. That you just have to go 180 minus those two other angles. All right, so I'm missing side B. I'm missing side C. Well, let's find B right off the bat. All right, to find side B, I am looking for side B, so I'm going to put B on top. And I'm going to put B on top of sine of B. Well, angle B is 40 degrees. And that's going to equal, once again, I'm going to pick a side and an angle that I know. I know side A, and I know angle A, so that's the one I'm going to pick. I'm going to put A over sine of A. Well, we multiply both sides by sine of 40. So we'll have B equals sine of 40 degrees times that A over sine of A, but we actually know that A value. That A value is 422 over the sine of A, but we actually know that angle. That angle is 30 degrees. So once again, I'm just plugging in my A value. I'm plugging in my angle A value there. All right, plug it in and double check my answer, but I got B was about 542.5.
Yeah.
That's good? Awesome. All right, the last one I have to do is I found side B. I know angle B. The only thing I have to find is side C. So we'll have C your way out, all over, actually I'm going to, C over sine of angle C. Angle C was 110 degrees. And that's going to equal, well, I'm just going to put that 422 over sine of 30 degrees because we already used that on the other one, so it's going to work on this one. So we'll have 422 all over that sine of 30 degrees. Once again, that's just A over sine of A. So we'll have C equals the sine of 110 times 422 over sine of 30 degrees. You should come out with C is about, bless you, side C is about 793.1. Questions on that? All right, I'm going to start the next one, and you're going to finish it. So we're just going to do a triangle. I'm going to note something. They're going with alpha and beta. So I'm going to label this alpha, beta, and gamma. That is just A, B, C. So you can replace that with A, B, and C if you really want to. I just want you to get a hang of knowing that there's two ways to write it. Well, alpha is 28 degrees, which means this is side A. That's opposite from our alpha. Our beta is 66 degrees. Side B is across from beta. And C is across from our gamma. So C would actually be here, which is 8.2. I'm going to note that this is angle, side, angle, so you can use the law of sines. Which means law. All right, I want you to do the rest.